All right, we're going to talk about 8.6 and 8.7, actually 8.5 as well, because 8.5 is kind of estimating this stuff. Okay, so scientific notation. I know you guys are messing with this in science, but it looks like this up here. Okay, so the factor in the front has to be a number that is greater than 1 and less than 10. In other words, a single digit number in here. So it could be 1.0, 1.1, 1.2, all the way up to 9.9, but it can't be 10, okay, because 10 is a 2-digit number. So this front number needs to be between 1 and 10, not including 10. And then this back number here, it depends what this is, but it is a power of 10. And we're going to use our exponent rules, like adding exponents when you multiply, subtracting them when you divide. We're going to use those rules because the base will be the same. So really, our exponent rules of having a base be the same is the reason why scientific notation exists. Because when we use these bases of 10, if we have another base of 10, right? So if I have another base, if I'm dividing and I have, 1.5 here, and then another base of 10, and let's just say it's, I don't know, let's say it's 3, then I can basically use the rule that says that when I have the same bases and I'm dividing, that I subtract. So negative 7 minus 3 would be negative 10. So when I divide this, I basically just divide, and we'll get into this in a second. I'm going to divide this 8.3 divided by 1.5, just the front numbers, I divide those, and then I use my exponent rules to figure out what my exponent is going to be with this base of 10. So let's look at what we're doing here. So here we're talking about these key ideas. So if the number is greater than 10, in other words, we're going to use this for really big, very big, and very small numbers. So 8,600, we would probably not use, this would not be a number we would probably even use scientific notation for. We would probably use it for like 8,600,000. But let's just look at what they're saying. So if it's a big number, then this is basically going to be a positive exponent, right? Because we're going to move it to the left. You can see the little hoopy things, they count 1, 2, 3 left, 3 to the left. So therefore, the decimal is now between 8 and 6, becoming 8.6 times 10 to the third, because we moved it 3. If we're doing a small number, which is numbers that have like 0.0000135, whatever it is, or 0.0024, they moved it to the right 4 to get it to 2.4, and then those are negative exponents. So it's positive exponents on big numbers, negative exponents on small numbers. That should be pretty easy to remember because it just makes sense. So then once you figure out how to get these in scientific notation, I really feel like that should be the easy part. If you're struggling with this, I'm going to stop talking about that. And in fact, I'm not even going to show you the examples. There are examples in your book if you're having trouble even after that explanation. But let's talk about the next section, which is 8.7, where we're going to actually use these to do operations. So adding and subtracting, multiplying, dividing. Multiplying and dividing are the same. Basically, let's talk about multiplying and dividing first. Multiplying and dividing, you're basically just going to multiply the first two numbers together. So you notice right here, they finally, you can forget all this stuff. Basically, they just took the first two numbers and multiplied them together, giving it 15. And then they used the exponent properties right here to say, okay, so I multiplied 3 times 5, so it's 3 times 5, and then I have 10 times 10 to the, negative 5 plus negative 2, right? Because it's basically doing 10 to the negative 5 times 10 to the negative 2, which, same bases of 10, so then I can add, because of the rule of multiplication, I can add the two exponents. So that's what I'm doing there. So basically, then negative 5 plus negative 2 is negative 7, and that's what I end up with. Okay? And then they moved it further down here. They moved it to 1.5. So now that I've got 15 times 10 to the negative 7, I move it to the left one place so that I have 1.5. And now when I go to the left, I just made my numbers smaller. Okay, I went from 15 to 1.5. So when I'm making it smaller, that's going to make my exponent get larger. So the number larger than negative 7 is not negative 8. Be careful with that. I feel like that's going to be the easiest mistake, is negative 6. And that's how they finished it. And you can see that. I'm going to erase all this because you can pause this and look at their step by step. And it's the same with division. So with division, instead of multiplying, all they did was divide this 1.6, this 1.5 divided by the 1.6. So they divide the front numbers. Then they use the division rule to say, right here, to say, okay, well, negative 8 minus negative 7 is negative 15. They end up with this 0.25 times 10 to the negative 15. Don't worry about this part. That's confusing. In fact, just in case you're taking screenshots, just don't even think about that. It's one of their weird ways of looking at it. But yeah, so I took the 0.25 times 10 to the negative 15, and I moved it to the right. So when I move it to the right, my number got bigger. And because it went from 0.25 to 2.5. So this number here got bigger. So 2.5 got bigger. So my number here, this 10, gets smaller. And smaller means a bigger negative. And that's this answer here. Okay. Lastly, adding and subtracting. Lastly is this adding and subtracting. And really, the hardest part is going to be remembering all those things I just said about if you make the number bigger, then the exponent gets smaller. If you make the number smaller, the exponent gets bigger. Using that here because, sorry, I don't really actually want to circle that. I wanted to use my laser. To use that here because if you look here, this already has 10 to the third. So you have to have the same base, not just the same base, but the same exponent. So the only reason that I can add 4.6 and 8.72 on this is because they are both 10 to the third. Okay? Because they're both 10 to the third, I can just add these two numbers together and I get this. And then I move to my scientific notation. That's all that happened there. So once I'm done, pause this and look at this screen. I'm trying to intentionally keep it blank so you can look at their work. This one here, notice that they did not have the same. This one's a negative 2. This one's a negative 3. Okay, so I need to make this negative 2 smaller. I need to make it a negative 3. Did they use negative 3? Because you could use negative 2. No, they use negative 2. So I need to make this one bigger. So in order to make this bigger, I need to make this smaller. And to make 6.6 smaller, to make this negative 2, which is bigger than negative 3, I move it 1 to the left, which they did, and get 0.66. So I moved it 1 this way. This now is negative 2, right there. So now both of them are negative 2, and I can subtract 3.5 minus 6.6. And because it was subtraction, I would have had to do negative 2 because I wanted to be able to subtract 3.5 minus the 0.66. And then it turned out fine. So that's it, guys. Adding and subtracting, multiplying and dividing. You just want to remember to use the exponent rules from the cheat sheet, and then just trying to get the hang of scientific notation. I'm happy to work with you, but definitely glad you stuck this out. I highly recommend pausing this video and just looking at each one of these, and maybe even take a screenshot. But look at each one of these problems and make sure that it makes sense. And you should get through this easily. Talk to you guys later.